Good evening, everybody. In the last some lectures, we have learned about UV visible spectroscopy, which is a credit-based system for TY-based analytical chemistry. In this lecture, we will focus on the detector, and in the next three lectures are also associated with the detector. What are the detectors employed in UV visible spectrophotometer and colorimeter? Now, detector. What is the role of detector? It detects the radiation and convert it into a proper signal. So transmitted radiations are detected by the detector. So that is the role of detector. Let us focus on this, we can say the construction and working principle of the detector. First detector employed in colorimeter is phototube. The principle of phototube is based on the photoelectric effect. The photoelectric effect is nothing but the ejection of electron takes place when the proper voltage is applied across the two terminals. Now the phototube works on the principle of photoelectric effect. It consists of a evacuated glass or quartz tube fitted with photosensitive material. Now the glass tube is made up of photosensitive material. Now this photosensitive material acts as a cathode and wire acts as an anode. So there are two electrodes. One is cathode, another is anode. Anode is nothing but it is a wire form, and cathode is nothing but it is coated with photosensitive material. Surface of cathode is coated with photosensitive material. Across these two electrodes, 90 voltage or more than 90 voltage is applied. Cathode has a concave shape. The shape of cathode is concave shape. So, and inner surface of it is coated with photosensitive material such as alkali metal or alkali metal oxides. So, alkali metal or alkali metal oxides has a vacant last electron in the last orbital. So, that electron is capable of ejection of electron, capable of to eject the electron from the outermost shell. So alkali metal oxide has a we can say one electron should be the less, and this electron is utilized in the ejection for the ejection of from the metal oxide. When it is irradiated with electromagnetic radiation, when the surface of cathode is irradiated with electromagnetic radiation, when the light is light with a proper wavelength is that is electromagnetic radiation is bombarded on the surface of cathode, a photosensitive material emits the electron because it contains the one electron at the last outermost shell. So that one electron is capable to eject the from the outermost shell. So which plays a significant role. Emitted electron is then attracted towards the anode. So anode is nothing but it is a wire form. So anode where discharge at the anode, discharge of electron takes place, which are emitted from the cathode surface, and then current is produced in the circuit called as a photocurrent. So photocurrent is produced here when the discharge of electron takes place at the anode, and these electrons are ejected from the cathode. Now this cathode is made up of some alkali or alkaline metal oxide surface. The current produced is amplified and measured. So it is important. The current produced is that is photocurrent is produced is amplified and measured. The output is determined in terms of absorbance or percentage transmittance. Now absorbance graph is directly proportional, and there is a you can say inverse relation with transmittance is observed. The amount of photocurrent produced per unit time is directly proportional to radiant power of incident beam on the photocathode. Now, whatever the amount, whatever the photocurrent is produced per unit time is directly proportional to radiant power of incident beam on the photocathode. So, which quantity, how much quantity is focused with proper wavelength on the photosensitive material, that quantity is directly proportional to amount of photocurrent per unit time. So that is, you can say, main principle of the phototube. At 90 voltage, or more voltage across the electrodes, all emitted electrons from photocathode are attracted towards the anode. So if we apply a high voltage, nearly about 90 or more, then all electrons should be ejected towards the anode, which get discharged at the anode, and photocurrent is produced. Then that photocurrent is produced with the amplified system. Now this will be the typical phototube, which acts as a detector in colorimeter or spectrophotometer. Now this is you can say if h mu, that is a wavelength, that is a electromagnetic radiation, is strikes the surface of cathode. Now this is the photocathode. This is the photocathode. Now here we can say bombardment of electromagnetic radiation on the surface of photocathode takes place, where it is coated with some alkali or alkaline metal oxide. Now this alkali metal oxide, so that here is a when strikes the surface, when electromagnetic radiation strikes the surface of phototube, at that time ejection of electron takes place. This ejection, this is nothing but the ejection of electron. This is the electron. Now this electron is attracted towards the anode. This is the anode. This is the anode. And here we can say amplification system is we can say this is the amplification system. It is this tube is connected to the amplification system, and the signal photocurrent is recorded, and that photocurrent is directly proportional to amount of electromagnetic radiation incident per unit time. And this is nothing but the quartz tube. This is the quartz tube. With this content, I think this lecture will be useful to students, because this lecture will give the idea about the phototube, what first detector of the colorimeter, or you can say spectrophotometer. So with this content I conclude this lecture. Thank you very much for your patience listening.